Lifting a variety of cargo, equipment, and provisions is an integral part of sea transportation and ship operation. Lifting is a hazardous operation. To reduce the risks involved to a minimum, it should only be done by properly trained personnel, controlled by a work permit system. People who operate lifting installations must have extensive knowledge of the equipment they use, its limitations, and the forces involved in each lift. To put it more precisely, they must assess the risks involved in every lift as they plan it. In order to arrive at an effective plan, they must also have good working knowledge of all the lifting gear, frames, beams, slings, clamps, and shackles they're likely to use. This is not a simple task. That is why personnel who carry out any lifting operation on board ship should undertake the necessary training to ensure that they can perform the task safely.
We're going to come to port. Okay, now we're coming down.
Manufacturers of lifting gear must make sure that their products are certified to be suitable for the job, and that their safe load ratings are clearly marked. This information is there to assist the users of the gear in making the correct choice of equipment for each lift.
6,400 pounds, a choker. Let's take a look at the shackles and eye bolts first. We've got some small ones here. The rating's right on them. It's a 1/4-inch shackle, and it's rated for ½ a ton right there. Okay. Working load limit. And we have a range of them. There's a 1 ton. Goes on up. I guess they all are marked. 3 1/4 tons. We go right up to the big ones up here. That's 7 tons.
In many lifting operations, shackles and clamps will be applied as the slings are attached to the item to be lifted and the lifting block. It is most important that only undamaged shackles and clamps are used in accordance with manufacturer's certification. Any misuse of these items can result in the slings parting from the hook or the eye bolt, leading to damage or injury.
Let's take a look at them for safety here.
Got this one here.
That doesn't look too good.
Doesn't even have a proper.
That's just a bolt through there, right? Let's get rid of that. Why don't we get rid of that?
Okay.
Throw it over there. And I got another one of these. This has got a 12-ton rating, but looks like someone put a bolt in there instead of the pin. No, we can't use that. Let's just get rid of that right now. Okay, we got some eye bolts here. We got all different sizes. Oh, look at this one. This eye bolt looks like someone made up, welded a nut onto a bolt. I don't think we're going to use that one either.
Improvisation going on there.
There you go. But that's out of the way.
Slings come in various configurations: single, double, 3-legged, or 4, employing ropes, steel wires, and chains. Each sling will be terminated in a simple eye or thimble, link, hook, or clamp. Before use, each must be checked to ensure that they are in good condition, fit for the intended application, and that their terminations are undamaged.
Over here we got some wire rope. We have various sizes here. Just got to check a couple different things I'd look at here. This one I wouldn't use. This looks like it was just made on the ship.
Ow!
Yeah, that's that meat hook right there. That'll tear into your palm if you're not wearing gloves. I don't really like the looks of it. I wouldn't use it. Okay.
It is crucial that only the slings with the correct load rating and with the right terminations are used in each lift. To ensure this, A lift must be properly planned. So, what is involved in planning a lift? First, check the weight of the object to be lifted. Verify if this is indicated on the object or on its related documentation. If you can weigh the object, all the better. If not, its weight must be estimated. Do not try to guess it by lifting it manually. Regular-shaped objects usually provide an easy solution. Their volume can be simply calculated. For example, a rectangular-shaped object with length, width, and height can be measured in feet or meters, and the three measurements multiplied will give its volume in cubic feet or cubic meters. The volume of a cylindrical object can also be estimated by measuring its diameter and height, calculating the area of its circular side, and multiplying this by its height. Following this, find out what material the object is made of and the material's weight per unit of volume. Data tables are available to provide this information. Multiply this by the volume of the object to get its approximate weight. If the object to be lifted is irregular, the problem is slightly more complex. Some irregular objects can be segmented into several regular shapes, in which case each component can be measured and the weight calculated by the methods we have already discussed. Then the component weights are added together. If this method cannot be applied, the weight must be guessed at and a multiplying factor must be applied to provide a margin of safety. Always overestimate for safety. Once the weight to be lifted is known, check for any lifting devices provided on the object itself. For example, electric motors sometimes have an eye bolt for hitching a hook or a shackle for lifting. Other objects may have lifting plates welded to them with holes or rings for fitting lifting gear. These examples provide easy answers because the best lift requires the lifting gear to be hitched to the object vertically above its center of gravity to achieve balance. If the makers of the object have provided lifting points, it is most likely that the lift will be balanced. Here is an example of an electric motor being taken out of service. A single sling is hitched to the fitted eye bolt. This is a vertical hitch, and the eye bolt is vertically above the motor's center of gravity. The sling takes the full weight of the motor during the lift. The hook, the sling, and the shackle must be rated higher than the weight of the motor. This rating must be checked before lifting. The information is stamped on the gear by the manufacturer. Provided that the gear is in good condition and free from damage, it is safe to use within its rating.
Working load limit. 3.
Here is another piece of machinery being lifted by 2 vertical slings hanging from a beam. Because the slings are employed vertically, the 2 slings share the weight of the object equally. Logic would dictate that the slings should be rated higher than half the weight of the object. In fact, it is recommended that each of the slings should be capable of lifting the whole weight. Often the object requires more than one hitching point for a balanced lift, and a beam cannot be used. A common alternative is a multiple sling in a bridle hitch. Notice that neither sling is lifting vertically. With this method, they form an angle to the vertical. This angle, unfortunately, reduces the rated weight each sling can lift, and the greater the angle, the smaller the weight it can lift. The solution is to choose higher rated slings and shackles to compensate for this deficiency. Manufacturers of lifting equipment provide a table of data to help in the choice of a higher rated sling for a given angle of application. For example, a sling employed at 10 degrees from the vertical will be able to lift only 80% of its weight load limit. At 20 degrees, it may only lift 50% of its weight load limit. Here is another example of a bridle hitch employing 4 slings. You might think that each sling will take care of 1/4 of the weight being lifted, and only the angle of lift from the vertical needs to be taken into consideration when choosing the correctly rated slings. Unfortunately, in real life, this is not so. Experiments show that 2 of the 4 slings actually take most of the weight, while the other 2 only function in a balancing role and take only a small portion of the weight. During the lift, these roles interchange as the object is moved. It follows from this that all 4 slings must be rated capable of lifting half the weight of the object. One other consideration complicates matters. There are 2 different angles from the vertical involved in this lift, depending on whether viewed from the side or from the end. Of course, for safety, the larger of the 2 must be considered when choosing the correctly rated slings. Certain objects require the slings to be employed in a basket hitch. Choosing the correctly rated slings and shackles will be done on the basis already discussed. The narrower the sling angle from the vertical, the safer the lift, provided that the object remains in balance throughout. A spreader is used between the slings to ensure this. A choker hitch is frequently employed on round objects such as piping. In this application, the sling is wound around the object and fastened back on itself. In this configuration, the sling can only lift about 80% of its rated weight. One other factor that must be taken into account. The critical point is the angle at which the sling is hitched back on itself. This angle should be kept as close to the vertical as possible. Let's now look at some typical lifting operations frequently carried out on board ship. The overhead traveling crane is a familiar installation in an engine room, usually operated via a remote box with low voltage push button. Only authorized personnel should operate this installation. Another frequently used combination is a tripod structure and a chain hoist. This is a useful method of dealing with smaller loads where no fixed lifting installations are available. Great care must be applied when securing the sling around the load. The method of hitching applied must keep the load in balance. The operator of the chain hoist should wear protective gloves. Provisions, equipment, and personal belongings are frequently lifted on or off ships using a jib crane. This normally involves 2 or more operators. One to assist with loading the cargo net and securing it to the hook, and the other to operate the crane. Take care not to stand or walk under a load. A recognized system of hand signals must be used for communication between the operators. Occasionally, very heavy and irregular shaped loads are lifted on board employing special beams, frames, and multiple slings. In such cases, the complex scheme must be broken down into a number of simple hitch types and each application calculated separately. This is where proper training in lifting techniques is essential. On occasions, a tandem lift using 2 rigs is called for. Great care must be taken to ensure that the angle between the 2 slings does not exceed the point where the critical working load limit falls below that required for the lift. Hooks may be wired closed to ensure that the load does not slip. We have seen some relatively simple lifting operations which present no special difficulties if planned properly. There are occasions on board ship when unexpected difficulties arise, even with carefully planned lifts. One of the most frequently incurred at sea is a lift that must be performed while the ship is rolling. Naturally, this can lead to the load acting as a pendulum, which must be controlled. The use of several stabilizing ropes or tag lines is essential in such situations. In another example, a load may not have suitable hitching points, not allowing the use of conventional hitching. Necessity is the mother of invention, and clearly a solution must be found. In these cases, specialist advice should be sought before a lift is attempted with the application of temporary lifting points. Always report this situation to a superior officer. A load may slip in conventional hitching once the lift is underway and becomes unbalanced. In such cases, if possible, lower the load back to the ground and readjust the hitching. There may be height restrictions, and the available rigging is too long for the lift to take place. Again, this may be a case for modifying one of the conventional types of hitching. Always consult a superior officer before taking such steps. The lifting has to take place through an opening such as a door or hatch. The solution may involve the use of other rigging devices to assist with the transition of the load from one side to the other. The lift on each side has to be planned as if they were 2 separate lifts. Such a situation normally requires specialist advice. A load may require a complex set of hitching as it must be moved up as well as sideways. Extra vigilance must be applied, standing clear of the load and the area roped off. Such lifts are better left to the specialists, as it requires a multiple calculation and application of several rigging setups. They are normally carried out in the presence of supervising engineers. One man must be in charge when any lifting operation is in progress. What we have seen here is only a small selection of the lifting gear and rigging solutions that a seafarer can use to move cargo and equipment. The skill is to know what each piece of gear is capable of doing. Always check that the weakest link in the system is rated higher than the load requires. Only training and experience will bring about the required knowledge to plan and execute a safe lift. For further information, check out the companion training guide provided with this video.